In this video, we'll take a look at what things you need to know about the new Strata materials in Unreal 5.2 and up. Strata will allow you to make more complex and realistically layered materials in Unreal. In this video, we'll take a look at the overview of shading with Strata and how to approach making a few materials in Strata, like this silk, as well as some metal, glass, and coated plastic. This is an introductory video to Strata materials in Unreal. If you're using Unreal 5.1, some Strata nodes may look a bit different since they've been updated in 5.2 Preview 2, which is the version of Unreal being used in this video. Let's begin and take a look at how you can enable the Strata shading feature. To enable Strata in Unreal 5.2 and up, you'll be able to go to Edit, Project Settings, and then search for Strata. There will be three options here. There'll be Substrate Materials Experimental, which is the Strata system or Strata Shading System, which you can enable. And then there'll be Substrate Opaque Material Rough Refraction. This is a feature where if you have a coated layer that has roughness, it'll actually blur the layers below it. This is more physically accurate and realistic, but it will affect performance. And then finally, there's a Substrate Advanced Visualization Shaders, which is a debugging mode for Strata materials. Only enable this if you're going to use that debugging mode, otherwise it also affects performance, so it may be something you want to turn off in most cases. Once you've enabled the options that you need here, you'll be able to close this and you may have to restart Unreal for those changes to take place. So why use Strata? Well, Strata shading in Unreal takes a more modular approach where you can start to layer and blend your materials more accurately and blend different material types together. It's very similar to what offline renderers do, like V-Ray, Arnold, or RenderMan, except Strata in Unreal is targeted to doing this in real time at a much quicker pace. The main thing about Strata is it will allow for you to have more flexibility and control over your materials so you can build more complex and realistic materials. There's some important optimization features about Strata we will take a look at as well, but let's first take a look at how Strata materials are structured. So once you've enabled Strata, if you create a brand new material, and I'm just going to right click and create a material and call it m_strata, and you open it up, you're going to see something a little bit different than what you might be used to. You're going to see something like this and this. So quite a bit different from what you had before enabling Strata. And you'll notice that there's a few things that are no longer here that you used to have control for, like metallic and other things. Now we're going to talk about what each one of these do and how you can kind of work with the Strata shading system. If you're used to the Metalness workflow or the PBR workflow, that will change a little bit. You still can shade that way. Nothing's really drastically changed, but the setup might be a little bit different. Because as you can see here, we no longer have the Metalness control. And we'll talk about that in a moment. But let's first go over kind of what you do get with the Substrate slab BSDF. BSDF stands for Bidirectional Scattering Distribution Function, and you have a lot of controls here of how these materials scatter light. So the very first thing that we're going to take a look at is the diffuse or albedo. And this is where you can connect up your color or base color of your surface, and then you have this F0 and F90 connection here. And this is pretty much the reflection at the facing angle or the direct angle of the surface. So F0 is referring to the very center and kind of the point we're looking at directly straight, face on. And then F90 is determining the reflection at the grazing angle, at the side angle of this object. So that's what those two controls give you. The control of the reflection at the facing angle, F0, and the control and reflection at the grazing angle, F90. And then you also have your roughness, your anisotropy control. So roughness is the surface smooth or rough? Is it glossy or is it rough? If it's 0, it's very glossy. If it's 1, it's very rough. And then anisotropy is the highlight stretched in a direction? Does that material have some sort of surface that makes the highlight become stretched or elongated horizontally or vertically? So that's what anisotropy will control. And then finally, we have our normals, which we've already been used to in the past, just for your normal maps to fake the normals of the surface. And then shading tangent, same thing, we had that before. And then we have our SSS MFP, and this is the subsurface scattering or subsurface mean free path. And essentially what this is going to do is it's going to be the density of the material and affect the absorption and scattering of light on this material. So it's defined in centimeters, but there's a bunch of things you can do to control that in different ways. And that's going to be something we'll talk about a bit and that we'll have to use. And then there's also scale control for it, and then an anisotropy control for it. Now, what does the SSS phase anisotropy control do? Well, pretty much you could think of it as if it's positive values, it takes the light and does forward scattering. And if it's negative values, it's backward scattering. And if it's zero, it's kind of scattering kind of in both directions evenly. So that's kind of what the SSS phase anisotropy will do. And then we have our emissive color if you want things to glow or give off light or just be emissive. And then we have a second roughness control and a second roughness weight. So what this is you have a normal highlight determined by your roughness up here. This will be the control of a secondary highlight. And that could be useful for if you're doing skin or certain materials, and you don't have to have that turned on. The second roughness weight is a control that you can add where if it's set to 0, it only uses one highlight from your roughness up here. And if it is set to 1, it's only going to use your secondary highlight, which is defined here. And then if it's set to like 0.5, then it's going to use half of this highlight, half of that highlight. So that can give you more control and kind of allow you to dial in two different types of glossiness or roughnesses for your fall off of your highlights and allow you to make more complex surfaces. But you don't have to enable that. It's all based on whether you have that second roughness weight turned on or turned off, or a mix between the two. And then finally we have our fuzz roughness. So this is like on top of this surface, you have a control now for a little bit of fuzz, and it kind of emulates fuzz on the surface. So you have fuzz amount, fuzz roughness is that fuzz kind of more rough or more glossy, and then the color of that fuzz. And this is all within this material called substrate slab BSDF. Now, what is a slab? Think of it as like a layer of matter, a layer of something. If you have paint, that's a slab. If you have metal, that's a slab. If you want to blend those two together, you can in Strata. So slab is kind of like a material type or a slab of something, a slab of a material. And then on top of that slab, you have this fuzz that's slightly added. And they refer to that as like the interface of the slab. But pretty much that gives you your material. Materials are known as slabs now. So if you right click and you search slab, you'll find your substrate slab and you can create another one of these. And that's where you'll be able to define what that material is. So that hopefully gives you a bit of an overview of what all these little different connections do. Now, one thing to keep in mind is terminology is a little bit different now. So reflection at the facing angle is F0, reflection at the grazing angle is F90. What happened to metallic? What happened to all that? There are still nodes that you will see that make use of the metallic option, and they'll have outputs. I'm just going to use a node for example here, just to go over kind of how the terminology will vary and how you can kind of link that together. There's a node called SMF, so strata material function underscore metal, and it gives you some inputs that you might be used to: base color, roughness, you got haziness, normal, stuff that you expect. Now, what's edge color? So if you ever see the word edge color, essentially that's the same as F90. It's the color or the reflection at the edge, the grazing angle. So if you see edge color, that's interchangeable with F90. Both those things pretty much mean the same thing. And if you see specular or facing angle, that's kind of the same as F0. So I just wanted to make sure that that's fairly clear. Now, if you did want to use a material that makes use of the metallic workflow where you have metalness or a metalness map, And if you're used to working that way, you can also create a node here called Metalness. And you'll see here under Substrate Helpers, there's Substrate Metalness to diffuse color F0. And what this node will do is allow you to use the metalness workflow. You define, is something metallic? And then you define if you want to change it specular or just leave it by default to its default brightness, and then its base color. And that way you can kind of work in the metalness workflow and then just connect this stuff up, diffuse albedo to diffuse albedo and F0 to F0. And that's really it. And it will just work. So if I want to make this chrome, I could do diffuse albedo, connect, F0 to F0, connect. Metallic, I'll put a constant. It is going to be a metallic, so 1, it's metal. And then base color, I could put my constant 3 vector and make it just bright white. Maybe it's not perfectly what we want it to be. And then you define your roughness. So roughness for this, I'll just put a constant in, 0 being super glossy, not rough at all. And there we go. We got ourselves like a chrome or like a mirror-like material in Strata using this metallic kind of workflow. So that's kind of how you can start to build things up. There's many different ways you can do this, and we're going to explore how you can create something like gold in a couple different approaches, just so it makes sense of how you'd approach things that you might already be used to doing, not in the Strata shading, but with the traditional Unreal shading. This way it'll help you kind of grasp how you'll be able to create materials in Strata. So since we already have this chrome that we just made already open, how can we turn this into gold? So all we'd really have to do is tint our color here that we're using. And that would, since we're using metallic mode, it's going to use base color as your reflection color. It'll kind of be able to produce gold if we modify these color values. So for something like a low carat gold, I'll maybe do something like 0.97 for red, 0.72 for green, and zero point 0.4 for blue. And that's technically taken from kind of real world sampled values of a gold, and a lower carat gold, like 14K gold or something. But that pretty much gives us something like a gold material. And maybe we add a little bit of roughness, just make it a little bit blurry. And we pretty much have a light carat gold there. So that kind of gives us our gold material. And if we want to do this now without using this metallic workflow, so right now we're kind of using the whole PBR metalness kind of approach or workflow. If we didn't want to use this node here to do that, how would we create gold using the specular workflow, which Strata also allows you to do? So if we want to create this with the specular workflow, I'm going to remove this node. It's pretty much the same thing. The only difference is you have no more metalness control. And in the specular workflow, you have diffuse separated. Your diffuse color is separated from your reflection or specular color. So you'll connect diffuse up, but it will be, ideally for a metal, it's going to have to be black. You don't really want any diffuse for metals when using specular workflow. And our reflection at the facing angle, by default for dielectric materials or non-metallic materials, your facing angle reflects a much lower percentage than the grazing angle. The grazing angle will always reflect 100%. So you can see here that it defaults to 1.0, 100% reflection at the grazing angle. And the facing angle, by default, anything that's kind of dielectric, non-metallic, most things will reflect 4 to 7% at their facing angle. And you can see the default here defaults to plastic, which is 0.04 or 4% reflection at the facing angle. Now, if we're making this a metal, metals reflect much more, even at the facing angle and the grazing angle. Practically everything about metals is all based on reflection and a little bit of a tint because it absorbs certain wavelengths of light more than others. So if we want to make this gold, all we need to do is pop in a color to facing angle reflection and set it to be our gold color. So 0.97, 0.72 for green, and 0.4 for blue. And that will bring up the facing angle to be a much higher reflectivity. And there we go. We have our gold in the specular workflow, not using metalness. So it doesn't matter which way you produce materials using the metalness workflow, using the specular workflow, they're both doing the same thing. One's not better than the other, except with the sense of saying, if you used a metallic workflow, since there's no use for having diffuse color separated from specular color, it can technically save some material slots or some textures that you might have to load. So in a sense, metallic workflow will require less things to connect up, but otherwise it doesn't matter which one of these methods you choose. Just two different ways to produce the exact same thing. Now it would be a shame to start using this Strata shading system and not make use of one of the features that we have here called fuzz. So let's take a look at how we can make some silk. So I'm just going to delete these connections away and we're going to take a look at how we can make some silk. So if you want to create a silk material, which is a fabric that's kind of hard to make because it's kind of like a metal. Like when you look at silk, it has a very shiny reflection. It's smooth or very kind of glossy-ish, but it also kind of tints the reflection if you look at silk. And the reason why this happens is because silk has a special structure on the way that the strands are. Like silk material has this kind of prism-like structure that gives you a bit of a iridescent or tinted reflection. So how can we produce silk in Strata or in the Strata Shading System? Well, what we'll do is think about what kind of color silk we want. Maybe we want red silk. I'll go in here and create a red colored material. I'm not going to make it too bright. I'll choose something like a dark red, something like that. It should be fine. And I'll use that for a diffuse color. Next thing we'll do is roughness. If we look at silk, is it rough? Is it smooth? It's fairly smooth, but it does have surface breakup, so it's not going to be like zero roughness. Maybe something like 0.5, 0.8, 0.7 around there. Let's kind of dial in some values. Be 0.8. Kind of okay. Now, right now, if we take a look at this, looks a little bit strange. We could use maybe some reflection tint. It feels a bit washed out. If this is like 0.2 for roughness, okay, it feels like a kind of plastic ball. But if we put this at 0.8, it starts to really get washed out. And as I mentioned, silk does have a structure where, since the fabric is kind of this prism-like structure, it will kind of give you highlights that are a little bit tinted or have this kind of unique look to it. So a way we can cheat that is let's take our facing angle 0 and connect it up to our color here. And that's going to tint the facing angle highlights to kind of emulate what silk does. A little bit of a cheat, but should be fine. And then we're going to add some anisotropy so that the highlights are stretched. So I'm going to go in here and maybe dial in something like negative 0.7, and that should give us vertical stretch in our highlight. There we go. Maybe negative 0.75, even more stretched. Okay. And then finally, let's make use of this roughness. So what about the fuzz that's on here? I'm going to create some parameters here. Fuzz roughness, fuzz amount. Fuzz amount, let's do 0.9. A lot of fuzz. 0.9, 0.8. 8.9 is too much. You get kind of these darker edges. So let's do 0.8. And then fuzz roughness, probably not very rough. So let's do 0.2. It's kind of smooth. Okay, now we get like a interesting kind of fall off on the edges. And then fuzz color, I'm going to add a constant, so some sort of color. I could use the same color I had here for the diffuse, but I think having a little bit brighter, more saturated color will give it a little bit more of a pop and give us those really nice highlights. So I'm going to choose like a pretty saturated and bright red for the fuzz color. And there we go. We kind of have like a silk-like material now, pretty easily done. And if we put this on one of our objects, it should hold up pretty well. And we can expose all these to parameters so we can just change the color really easily. But this is kind of how easy it would be to create some silk-like material in Strata. So let's put this to work and give it a try. I'm going to save this material and just minimize this window once it saves. Here's our little box with some cloth draped on top of it. Let's apply that silk material to this cloth. And there we go. That's kind of the silk we were able to create super easily. And it looks pretty good. It has this very nice shiny highlight. It feels like silk. You could probably dial it in even a bit better or make some adjustments to even get it to look better than what we have here. But this is a pretty good starting point. So now we're able to produce silk in Strata very easily. Now, what about refractive materials or materials that you can see through, that light can pass through, like glass? How can we make glass in Strata? So I'm going to open this back up and we're going to make some glass. So I'm going to delete all this, no more silk, and we're going to look at how we can create some glass. So very first thing about glass with Strata is we have to make some changes here. If we click on Strata, or right here, we'll see that there's an option for refraction and it's disabled. So how can we enable that? Well, to enable that, we're going to have to go in here to our details and enable refraction. So what I'm going to do, the easiest way to do this is we can just search or go to the drop down here called refraction. And right now refraction method is set to none. So I'm going to change that to index of refraction. And index of refraction will be kind of the most realistic way of calculating refraction, or how light gets passed through this surface and how it gets bent when it passes through this surface. So you can look up a Wikipedia page or any index of refraction from a textbook for how different transparent or refractive materials refract light differently. So we're going to set this to index of refraction, but it'll still show as disabled here. Like we can see it says index of refraction, but it's grayed out. And that's because we also have to change our material type. So we're going to go to material here, and right now you'll see our blend mode is set to opaque. We're going to change that to translucent colored transmittance, and that will allow you to do kind of tinted refraction. It will pretty much calculate diffuse and translucency, so it's like a fully featured um, refraction type material, whereas translucent gray transmittance and color transmittance only do certain things. I'll have more information about that in the PDF for this video, but pretty much for this glass, I'm just going to choose translucent colored transmittance, and that's going to give us kind of the most detailed material for translucency. And after doing that, I'll be able to have access to this refraction. So refraction for something like glass, depending on the type of glass, is probably anywhere from 1.4 to 1.6 or something. I'm just going to do 1.57 or something. That should be fine. 1.48. I don't know. Like for glass, it's within that range depending on what type of glass it is. Now, we'll notice here, this doesn't really look like anything we'd expect right now. How can we make this properly look like glass? Well, once I've dialed in that index of refraction, you know what, maybe I'll do 1.4, a little bit less refraction. So that'll determine how it bends light, or how this glass will magnify or distort the image behind it. And then for glass diffuse, this is going to be pretty much black. I don't think we want any tint to it in this case. Roughness, we're going to set to probably 0, but I'm going to do 0.1 for just a little bit of roughness on this glass, and I'll go over why. It's kind of going to be a neat thing that we'll be able to do with Strata. So I'm going to set roughness to 0.1. And then why doesn't this look like glass? It just looks like a dark cube. That's because we have to set the SSS mean free path. So for something like glass, it pretty much is going to be a very large value. The SSS MFP, or mean free path, will determine the absorption and scattering of the material. And for glass, it's going to be a very large number, since light can easily pass through it without much absorption or scattering. So what we're just going to do, we could technically plug in just a high number, like 1 or something would be fine. But instead, what I'm going to do is use a node called Substrate Transmittance to mean free path, and that will allow me to take a transmittance color. So if I want to, I could tint the glass as well. And I'm just going to connect this to white for now, since we just want see-through glass with no tinting of any sort. And now we kind of get this glass that we can see through. And it'll probably look a bit better to troubleshoot in our scene with an actual proper geometry, but here we go. We got some glass, and that's pretty much it. So if I save this and we apply it to like a thin cube, we'll get some glass. So now that this material is saved, I'll minimize it, go into my scene. I'll have like a cube here that's fairly thin. I'll make that a bit thinner. There we go. That's good. And I'll put that glass material we made onto it. And there we go. We can see through. It distorts the image behind based on that index of refraction. And there's our glass. Now, the cool thing about this is if you enabled that feature that I talked about earlier under Edit, Project Settings, when you search Strata, if you enabled Substrate Opaque Material Rough Refraction, it will allow kind of rough refraction effects. So it'll kind of do this effect if you layer materials. But this is the cool thing about Strata. It's a much more complex shading system. And if you have a material like this, and I just expose maybe our roughness as a parameter and just call this roughness. And I'm going to make this a instance material so I could easily change that. And you probably want to expose more things. But I'm just going to create a material instance, apply that on here. And let's take a look at that adjustable control. So I got my roughness control here. Check out what happens when I make it more rough. It becomes like blurred glass, and it actually blurs the image behind it. And this is really cool because without Strata, this is always an effect that you kind of had to cheat a little bit. Whereas now you get proper or somewhat proper blurry refractions if your see-through refractive surface has roughness on it. So pretty cool. A great thing to create blurry glass and more accurate materials that wasn't as easily done before. So that's a really neat thing that we're able to do now. And let's go back and take a look at one more thing. I'm just going to get rid of this plane here for now and just create a sphere. And if we put our glass on this sphere, we get our blurry refractions and all that, but we don't get a specular highlight. I don't get a reflection of the sun on this surface. And if we go into our material, which I'm just going to open up, and we look here, okay, well, our roughness is 0.1, but we don't get a specular highlight. And why is that? By default, you're not going to get that, even though it should be there. You're going to have to change the material a little bit. So I click on an empty space here under details. I'm going to scroll down, and you'll be able to find a section here under translucency called lighting mode. And by default, it's on volumetric non-directional, which is the cheapest method, but it doesn't give you all the features. The most expensive method is surface forward shading, where if I change to that, it's a heavier material. But what we'll get now is proper reflections and highlights calculated. So now we get that specular highlight. So if I were to save that and we have that surface forward shading, we essentially get refractive materials you can see through, and you also get the highlights calculated, or specular highlights calculated as well. So that's something important for if you're needing that. If you're needing surfaces that are refractive or transparent, but also have reflections and proper highlights. So what we're going to do now is create a bit of a film material, like iridescent film. So I'm going to open up this material that we have right now, our refraction one, and we're going to turn off refraction and clean this up a bit and make a material that has a thin coated film with a bit of iridescence. So let's delete out all these nodes here, and we're going to go and turn off our refraction. So under refraction method, just set that to none. And then what we're going to do is we also have to change our material type back to being opaque. So I'll just click on nothing here and change it to opaque. So it's not a refractive material. And what we're going to do is search for what we're going to do is we're going to make a thin film and then blend it with another material like plastic. So I can go in here and search for substrate operators, and we'll be able to find the types of blend modes. So we have substrate add, where you just add two materials together, coverage weight, horizontal blend, and vertical layer blend. So you have all of them here, and add will just plus two materials directly together, not physically correct, but pretty much just adding two things together. So that can cause a bit of problems where you'll end up with materials that kind of give off more light than they receive. So it's something you have to be a little bit careful with when using. Then we have a substrate coverage weight, where you can have this A go to whatever material you have, and then weight go to how much coverage or how strong that material is, and connect that up in a blend. And then we also have our substrate operators horizontal blend, which is blends two materials together, background and foreground, and then how you're mixing them together. So it perfectly blends those two materials directly, just mixing them together. And then there's also one other one, substrate vertical layer, which will simply just put one material on top of another. So bottom could be plastic, and then top could be something else, same top thickness. So it just pretty much puts one material on top of the other, and then you define how thick that top material layer is. So those are kind of the blend modes that you can use with Strata. Now, if I want to create something that has like a thin film, what we can do is do that very easily by using a node. So I'm going to go here and search for thin film, and we have a substrate thin film node. And that pretty much gives us a node where we can output our specular color to F0, edge specular color to F90, and then you have things that you can specify like our normal and F0, F90, thickness, and IOR. Now, thickness is the thickness of the film, and IOR is the index of refraction of the film. For thickness, I'm just going to put something like 0.14, and 1415 will give us kind of similar kind of look, but if you change that to different numbers, you'll get different looks of iridescence. So you can see how this looks at 0.15. Maybe we'll change it to 0.5, and you see a different kind of look. So 0.15 looks pretty good, so I'll do that, and IOR will also have a similar effect, where it will change kind of the look of it as well. So at 2, it gives us that kind of fall off. At 1.5 or 1.4, so it'll give us this kind of fall off. So this kind of defines how our thin film will look. Now we have our thin film. What if we want to blend this on top of some plastic or something? So that's kind of the next thing that we're going to want to maybe do. So what we're going to end up doing is going in here and adding another material. So diffuse for this one could just be black. We don't really care about having a diffuse, so it's just pretty much the thin film coating. Roughness will make it fairly glossy, maybe 0.1. So it's a little bit blurry that way. And that pretty much gives us our thin film layer. So now what if we want to make plastic or another layer below this? So we'll move this up here. We're going to create another slab. So we'll go in here and create another substrate slab. And we're going to blend this with the other one. But first we'll have to make this one as plastic. So what we can do is define the color. So I'm just going to do a constant 3 vector, make it something like a red kind of plastic. So we'll just dial some numbers in here to get a pretty bright red. And then what we're going to do is connect this to our front material just so we can preview it. And then we'll take the roughness. It'll be more rough. So maybe something like a value of 0.5. So we have a bit more of a plasticky material that's not too sharp or too smooth. And now what we want to do is blend this with our coating. So we're going to create a way of blending these two together. So we're going to go and create that vertical layer blend or vertical layer substrate, and plastic is going to be our bottom. Top is going to be the thin film. We'll connect that up to our front material now, and I'll just reorganize this a bit. And now what we're going to be able to do is have that one layer on top of the other one. But if we look at this, we only see our film. We don't see the plastic below. And this is because we need to change one thing on our thin film material. We need to define the SSS mean free path. So this is going to be pretty much the thickness of this, or how much light it kind of scatters or absorbs. Is going to be like the scattering of this. So we're just going to use substrate transmittance to mean free path, just like we've done before. And we're going to take this transmittance color, plug in a constant 3 vector. We're not going to make it perfectly see-through or white. We're going to go for a little bit darker of a value. So like a little bit darker gray. And that will just make this layer a little bit stronger, but still we'll be able to see through it mostly. And that pretty much will give us a decent blend between it. So now we have that iridescent film on top of our plastic, and it's blending nicely, and it's a pretty complex material that's properly layered. So this is starting to look pretty cool. So if we save this and take a look at it in our actual scene just to see what this looks like, that's our material. So now we have this iridescent coating on top of this plastic material, or this plastic, red plastic kind of material. So pretty cool. Now this is pretty expensive of a material, and you're blending two different materials like this. You can see the base shader pass is 3,278 instructions. That's quite a bit. That's because it's properly blending these two different types of materials. Now there is a way to optimize this a bit. We can go into these materials and how they blend, the substrate vertical layer, and turn on use parameter blending. And that will kind of collapse them to one material and just have differences based on roughness and diffuse and things like that, but not keep them as separated two different materials, but it'll try to combine them and optimize it. So it will change the look. It will damage the look a little bit, but it will optimize it quite a bit while trying to keep the look as similar as possible. And this will be improved over time, or that's kind of what Epic Games is saying. So it might not be working the best right now, but it might improve over time. So if we check that on, anything from this node downwards towards the left will be optimized and kind of collapsed to a material with just different values for roughness and all those parameters. So this is what it looks like currently at 3,000 instructions. And if we turn on parameter blending, let's see what happens. Okay, the look looks a little bit different, but now it's only 798 instructions. So it hurts the look a bit, but it's not too bad. It still keeps the overall feel. But again, 798 instructions, pretty much 1/3 of the original amount of complexity. And this is a great way to kind of optimize things, especially when you have much more complex materials. This will be a way of kind of getting it to a more simplified and a more faster running result. So that's kind of what parameter blending will do. And it does not do a perfect job of optimizing. It does change the look, but again, makes it much more simple in terms of instruction count. So that's kind of how that can be used. So now we're able to blend these two materials together. We're able to optimize. It kind of gives us a good start for what we're able to do in Strata with these materials and blending two different materials together. So that kind of brings us to a pretty good way of being able to also optimize this stuff by using that parameter blending. So anything from that node down, when you check that parameter blending on, will be optimized. Anything after it will not. So it kind of works from that node downwards. So that hopefully gives you a good introduction to shading with Strata. There's a lot more complex things we can do, but this is kind of just enough to get you started and kind of go over some of the things that you should know before you really dive into shading with Strata. If you like this video, if you learned something new, make sure to like, subscribe, and press the bell notification to be notified of future videos. And if you want to see a little bit more info about this topic, if you're part of the Patreon, you'll get access to the PDF here, which will kind of cover what we did in this video, but also provide a little bit more information on some of these topics. So definitely check that out. And the link to Patreon is down in the description below. Otherwise, please let me know in the comments of what other content you would like to see for future videos.